Hello students, welcome to my channel. Our today's topic of discussion is relation. Now this word relation is quite known to all of you because in your everyday's life around you, you can find so many relations out there. But in mathematics, by the word relation, we actually mean the relation between two elements of two non-empty sets. That is, relation involves pair of elements of two sets. Let's explain it. Suppose I am considering two non-empty sets. One is set A and the one is set B, right? And from A to B, I am defining a relation R. Here I am denoting it as R. You may take it as rho also. That means only those pair of elements of A and B will be in R, which will satisfy the definition of R, right? So in that way, we will get that R will be a subset of A cross B. Because as we have already discussed, I have already told you that the elements which will be in R must appear in pair, in ordered pair. Okay, so that is why R will be a subset of A cross B. So what will be the structure of R? R will contain the elements which are of the form of ordered pairs such that first element will belong to the set A, that means here small a belongs to the set A, and the second element will belong to the set B. So this is relation. So relation from A to B is nothing but the subset of A cross B, means the subset of the Cartesian product of the non-empty sets A and B. So here we get that if we say the ordered pair AB belongs to R, then it actually means that A is related to B by the definition of R, right? Where A belongs to the set A and B belongs to the set B, right? Now, if we consider only the first elements, I repeat, if we consider only the first elements of the ordered pairs which are in R, because R obviously will contain in general one or more than one elements, right? So now, and all those elements are in the form of ordered pairs. Now, if we build up, we consider only the first elements of those ordered pairs which are in R and make a set, then what will happen? Here we will get another concept, that is domain of R. That is, in that case, the domain of R will be constructed. So what is the domain of R, students? This means the set of all first elements of the ordered pairs which are in R. That is, which are in the relation. Okay. So we can write it as in the set form that it contains those A's, that is the first element, right? The first element of the ordered pairs which are in R, where A, that is the first element, belongs to the first set, which is also known as the domain set, such that the ordered pair AB belongs to R for some B belongs to, it is known as codomain set, B belongs to the codomain set capital B. So this is the definition of domain of R, that is domain of any relation. That is, domain of any relation means the set of all first elements of the ordered pairs which are in that relation. Now another very important concept derives from it, that is concept of range of a relation. Now what is meant by the range of a relation? The range of R, the relation R, means the set of all second elements. As in the domain we have considered the first elements of the ordered pairs. Here in range we are considering the second elements of the ordered pairs which are in R, right? So range of R means set of all second elements of the ordered pairs which are in R. So we can write it as in the set form that range of R will contain those B's which are in the codomain set, that is in set B, such that this ordered pair AB belongs to R for some A belongs to the set A, domain set A. So this is the definition, this is the concept of range of any relation. That is, range means the set of all second elements of the ordered pairs which are in R. So we have already got the concept of relation, the domain of relation as well as the range of relation. Now let's try to solve this problem with these concepts. Here it is given that A is a non-empty set containing the elements 1, 2, 3, 4 and 5. B is another non-empty set containing the elements 2, 4 and 6. A relation from A to B is defined this way, that this is denoted as capital R. R contains those ordered pairs which are in the form of AB, where A belongs to the set A and B belongs to the set B, where B is divided by A. This is the main thing. B is divided by A means only those ordered pairs of A cross B will be in R, will be in this relation R, in which we will find the second element is divided by the first element. Now under this condition we have to build up R. We have to find the domain of R as well as we have to find out the range of R. So now let's see what will be the structure of R here. So here we get A is containing 1, 2, 3, 4, 5. B is containing the elements 2, 4 and 6. So what are the elements of A cross B, students? Hope you have already got it. That is Cartesian product. The elements of the Cartesian products of the sets A and B are of the form 1, 2, 1, 4, 1, 6. With commas they will be written. Then comma 2, 2, comma 2, 4, comma 2, 6. Comma 3, 2, 3, 4, 3, 6. Comma 4, 2, comma 4, 4, comma 4, 6. Comma 5, 2, comma 5, 4, comma 5, 6, right? Now, out of those elements of A cross B, only those elements will be selected for R to be in R, where we will find that the second element is divided by the first element. So, let's try to make the set R. So, here R will contain which elements? First of all, 1, 2, because 2 is divisible by 1. Then obviously 1, 4. As 4 is divisible by 1. Then 1, 6, as 6 is divisible by 1. Then 2, 2, because this 2 is divisible by this 2. Then 2, 4, obviously 4 is divisible by 2, so it will be included. Then 2, 6, by the same reason. Then 3, 6, as 6 is divisible by 3. And then 4, 4, right? Only these elements of A cross B will be in R because they are satisfying the definition of R. Now from this structure of R, we can easily get the domain of R. So what will be the domain of R? Domain of the relation here is containing the first elements, right, of the ordered pairs. So here we get 1 as the first element, then we get 2, then we get 3 and then 4. So 1, 2, 3, 4. These 4 elements will be in the domain of the relation. And what about the range of R? As we know, the set of all second elements. So here we get 2, then we get 4, then we get 6 4, 6, these three elements will be contained in the range of R. So thus we can build up the R, the domain of R as well as the range of R. Now let's see how many types of relations are there. On the basis of the structure of R, we get basically 4 types of relations. Though there are some special types of relations and I'll also discuss about them in next video. Now in this video I am discussing about those basic 4 types of relations. The first type is inverse relation. Inverse relation. The second one is empty or void relation. The third type is universal relation. And the fourth type is identity relation. Now let's explain each and every relation one after another. Now let's see the first type, that is the inverse relation. Now obviously the type of this relation is quite clear, I suppose, to all of you. From this word inverse, that means this relation is the inverse of some other relation. So let's explain it. Suppose I am considering two non-empty sets, A and B, and a relation R is defined from A to B. Okay, then we know that R will contain the elements which are in the form of ordered pair, where A belongs to A, set A, and B belongs to set B, codomain B, right? Now what about R inverse? R inverse means the inverse relation of R. It is denoted by this symbol. It will contain the elements of the form BA. So these elements of the ordered pair is just interchanging their position, right? So we get AB belongs to R, where A belongs to the set A and B belongs to the set B. So this is the definition of the inverse relation of a particular relation. That is, if the relation contains the elements of the form AB, ordered pair A, B, then inverse of it will contain the elements which will be of the form B, A, where AB, the element AB obviously is in R. So from the structure of inverse relation, means R inverse, it is clear that this is the relation from B to A. Okay, now let's explain this concept with an example. Suppose I am considering an example like a non-empty set A which contains the elements 1, 2, and another non-empty set B contains the elements 2, 3. And suppose I am structuring R as 1, 2 and 2, 3. And if I now ask you what will be the formation of R inverse, then from this illustration we can say that R inverse will contain the elements of the form 2, 1 and 3, 2. That is, the elements of the ordered pairs will just interchange their positions. So this is the concept of the inverse relation of a particular relation. Now let's consider another type of relation, that is empty or void relation. Now when a relation is said to be empty or void, let's explain it. Suppose I am considering two non-empty sets A and B, and I am defining a relation R from A to B. Then we know that R will be a subset of A cross B, right? But if we get no such element in A cross B which satisfies the structure or the definition of R, then what will happen? Obviously R will be an empty set, right? So R will be empty if no element of A cross B satisfies the definition of R. So in that case, we will get that R is an empty set, right? And this relation R is said to be the empty or void relation. Okay, so when a relation is said to be empty or void relation, if when we build up the set of R, we find that no element of the domain and codomain sets, means no element belonging to the Cartesian product of the domain and codomain, satisfies the definition or the structure of R, then we shall say that R is an empty or void relation. For better understanding of the concept of void or empty relation, let's see this example. Suppose I am considering a non-empty set A which contains the elements 1 and 3 and another non-empty set B containing the elements 5 and 7 suppose. Okay, and I am defining a relation R such that R will contain only those ordered pairs of A cross B where that is of the form A comma B, where A belongs to capital A means set A and B belongs to the set B, and A into B will give an even number. Okay, suppose I am defining R in this way, right? Now let's see what is the structure of R under this condition. So here we get A is 1 comma 3 is containing 1 and 3 and B is containing 5 and 7. So what are the elements of A cross B? That is Cartesian product of the sets A and B. The elements are of the form 1, 5, ordered pairs obviously we know, 1, 7, 3, 5, 3, 7, right? Now let's multiply them. Multiply the elements of each ordered pair. 1 into 5 gives us 5, which is obviously an odd number. 1 into 7 is 7, which is another odd number. 3 into 5 is 15, obviously odd number. 3 into 7 is 21, is also an odd number. So do you get any such element in A cross B which satisfies the definition of the relation R? Just pause the video and think over it. Yes, I hope you have got it. The answer is no. So what will be the structure of R? Obviously, R will be an empty set. So here, R is an empty set. I hope it's clear to all of you. So, relation R is an empty or void relation in this example. Hope the concept of empty or void relation is clear to everyone. Now let's consider another type of relation, that is universal relation. Now when a relation is called the universal relation, let's explain it. Suppose I am considering two non-empty sets A and B again, and a relation R is defined from A to B. Now according to the structure of R, if we find that R contains all the elements of A cross B, then obviously we can write that R is equals to A cross B. And if it happens, then we shall say that R is the universal relation. Universal relation. Now let's explain this concept by an example. Suppose I am considering a non-empty set A which contains the elements 2, 4. Another non-empty set B contains the elements 3, 5. Okay. Suppose I am defining a relation R from A to B, like R will contain those ordered pairs of the form AB, where A belongs to the set A, B belongs to the set B, and A into B is an even number. Okay? So R is defined this way. Now let's see what is the structure of R in this case. So here we get A is containing the elements 2, 4. B is containing the elements 3, 5. Right? So what about A cross B? Obviously the elements will be of the form ordered pair, will be in ordered pair, right? So here we get the elements of A cross B are 2, 3, 2, 5, 4, 3, 4, 5. Right? Now let's multiply each elements of the ordered pairs, of each ordered pair of A cross B. From 2 and 3, we get 2 into 3, that is 6, even number. From 2, 5, we get 2 into 5, that is 10. From these two numbers, we can write 4 into 3, that is 12. From these two numbers, we get 4 into 5, that is 20. So here the product of these elements will give us 6, this will give us 10, this will give us 12, this will give us 20. And each number is the even number. Okay? So here we get that R is equals to A cross B, means all the elements of A cross B are satisfying the definition, the structure of R. So in this case, R is the universal relation. So R is universal relation. Hope the concept of universal relation is clear to everyone. Let's take another very important type of relation, that is identity relation. Identity relation. Let's explain it. Suppose I am considering a non-empty set A. Okay. Now, if a relation is defined on A such that all the elements of A, I repeat, all the elements of A are related to itself only by that relation, then we shall say that particular relation is the identity relation on A. And here there is a standard notation of the identity relation, that is IA. So IA will get the structure like AA. The ordered pairs will be of the form AA, which are in IA, such that A belongs to the set A. Okay? So in identity relation we get, in identity relation, IA, we get that every element of A is related to itself only. Okay? So this is the structure of the identity relation. Let's explain this concept by an example. Let's consider a non-empty set A which contains the elements 1, 2 and 3. Then if we define a relation on A and we find that each element of A is related to itself only, then that relation will be the identity relation of A. Then what will be the structure of IA? IA will contain in that case only the elements which are of the form 1, 1, 2, 2 and 3, 3 only. So this 3 will be the elements only of IA. So hope the concept of identity relation is clear to everyone. So in this video we have got the definition of relation as well as we have seen 4 different types of relations. Hope this video will help you. Make sure students, there are a few more special types of relations and in my next video I'll discuss about them. Till then, take care, stay safe and thank you so much.